everyone, we're going to use the comparison test to determine whether the integral converges or diverges. From 1 to infinity, we have the square root of x to the power of 7 minus 5 divided by x to the power of 4 dx. All right, it has this form. We're going from 1 to infinity. So we're going to use this number 1 part here for integration. So we're going to compare it also. Let's just leave out that negative 5 there and write it as 1 to infinity. And then we're going to compare it to just square root of x to the 7th divided by x to the 4th. All right, dx. So this can be written as using this, the limit as b approaches infinity, changing this to b and then 1. Rewriting this is x to the 7 halves divided by x to the 4th dx, which equals, if you simplify this, the limit as b approaches infinity of the integral from 1 to b, and if you simplify this, is going to be x to the negative 1/2 dx. All right, now let's integrate this. We're going to get the limit as b approaches infinity of 2 square root of x. And we're evaluating from b to 1, which equals the limit as b approaches infinity of 2 square root of b minus 2. And so this goes to infinity. That means it diverges. Now looking at our theorem, if it diverges, then that's your f of x. So this is going to be our f of x. And this has to be smaller than our g of x. But our g of x, if you call this g of x, this is actually smaller. So we have the square root of x to the 7th minus 5 divided by x to the 4th is actually less than square root of x to the 7th divided by x to the 4th. If this was convergent, this would be fine, but it's not, it's divergent. So we're in the wrong direction. For direct computation. For a direct comparison test. All right, because this, since it diverges, we need to be here. This needs to be here, and this one needs to be here. All right, so we're going to use the limit test for improper integrals and compare the limits. So we're going to write our f of x. Now we're calling this f of x the limit as b approaches infinity, and we have the square root of x to the 7th minus 5 divided by x to the 4th divided by what we compared it with, which was square root of x to the 7th power divided by x to the 4th power. These cancel out. So we get this equals the limit as b approaches infinity of square root of x to the 7th minus 5 divided by square root of x to the 7th. Now, when you substitute in a large number for this negative 5 is not going to matter, and it's going to divide out to 1. A large number divided by a large number is 1. All right, so if you get 1, that means they behave alike. All right, since they behave alike, by our limit comparison theorem, that means we already know that our one we chose is divergent. Therefore, this is also divergent. Our function square root of x to the 7th minus 5 divided by x to the 4th dx diverges as well. Thank you. Have a nice day. Bye-bye.